Yes, good afternoon, students. Please inform others to join this particular stream because there was some problem in the previous stream, so I couldn't continue in that stream. Please ask your friends to join this stream. Yes, good afternoon, Sanjay. Yes, good afternoon, all of you all. There was some connectivity problem with that stream, so I'm starting in this stream. So inform others to join this stream. Yes, good afternoon, Shantanu, Rushil, Arya, Amrita, Rahul, all of you all. I'm just going to look for I'm just going to share this stream. Yes. So students tell me what were we doing in the previous lecture? Were we doing MCQs or numericals? What were we doing? Can you all tell me? Yes, can you all numericals we were doing? Okay. And in numericals, what were we doing? Which module were we on? I'm just going to straighten this a bit. Yes. Module 5. Module 4 done. Okay. Students, just confirm that do we have to start with module 5? Just confirm. Do we have to start with module 5? Just confirm with yes or no. Okay. So let us continue with module 5. And which question 8 of module 5? Okay. Question number 8, module 5. So we are on page number 41, question number 8. Page 41. Yes, so all of you all. I'm sure you are able to see the board now. So question number 8, page 41. So a stretched wire emits a fundamental note of frequency 256 Hz. So we are given F, fundamental frequency N as 256 Hz. Further it says, keeping the stretching force constant and reducing the length of the wire by 10 centimeters. So L2 is L1 minus 10. The frequency becomes 320 Hz. So N1 and this is N2 is 320 Hz. Calculate the original length of the wire. We have to find L1. Okay, we have to find L1. Is that clear, all of you all? Now, students, this is 256. We know that for a stretched wire, frequency is inversely proportional to length. Frequency is inversely proportional to length. So we can say N1 upon N2 is L2 upon L1. N1 is 256 upon 320 is equal to, instead of L2 we can write L1 minus 10 Yes, Vilas Kalamkar, correct answer. So if you divide this with 16, 16, 16 and 16 20s is equal to L1 minus 10 upon 10. Now 8 and 10, 18. So L1 becomes equal to 18 centimeters. Just verify whether the answer that we got is correct or not. Question 8, 50 centimeters they are getting. Okay, L1 is not 10. Correct. This is L1 only. Correct. That's error from my end. I have rectified it. Now just cross multiply this and you will get the answer. Okay, if you cross multiply this, you should get the answer. If you want, you can divide this with 4. 4 4s and 4 5s. Now cross multiply. So 4L1 I hope it is clear now, everybody. Yes, you all can just refresh and it is clear now. And hopefully you are able to see that answer comes out to be 50 centimeter. Let us proceed now, everybody, with the next question. I'm going to erase this question. Question number 9 is same as question 7th. Question 9 is similar to question 7th. Next, question number 10. Let's start with question 10th, everybody. A transverse wave is produced on a stretched string 0.9 meters long. So the length is 0.9 meters. Find the speed of the transverse wave when the string vibrates while emitting second overtone of frequency 324 Hertz. So second overtone and the frequency is 324 Hertz. Frequency of pth overtone, all of you all. Frequency of pth overtone. What is the formula for frequency of pth overtone? Frequency of pth overtone is given by p plus 1 upon 2L root of t by mu. Correct? Now, this frequency is 324 Hertz. Overtone is second overtone. So 2 plus 1 upon 2L and root of t by mu is nothing but velocity. Root of t by mu is nothing but velocity. So if we try to solve this, the length is given as 0.9. Now just cross multiply this, so you will get the answer for V in terms of meters per second. Ankit, this is superposition of waves. The name of the chapter is superposition of waves. Moving on. Let us proceed with the next question. Question 11th. Question 11 says, what should be tension? So we have to find the value of T applied to a wire of length 1 meter. So length of the wire is 1 meter and mass is 10 grams. Mass is 10 grams. If it is to vibrate with a fundamental frequency of 50 Hertz. Fundamental frequency of 50 Hertz. So the question is comparatively easy. What is the formula for fundamental frequency for a string? 1 upon 2L root of T by mu. And what is mass given to us, everybody? What is the value of mass given to us? 10 grams. So we can rearrange this as mu is mass per unit length. Mu is mass per unit length. So now on rearranging, you can say 1 upon 2L under the root of TL by M. Under the root of TL by M. Now students, substitute the values correctly. So 50 is equal to 1 upon 2 and length is 1 meter. Root of tension we don't know, length is 1 meter and mass is gram. So into 10 raised to minus 3 kilogram. Into 10 raised to minus 3 kilogram. Now solve this properly and you will get the answer for tension in standard unit, and it's a force, so the unit is going to be Newton. Unit is going to be Newton. So make sure, everybody, that you are converting gram to kilogram. Do not make a mistake there, otherwise the question is quite straightforward. Yes, those who are answering 100 Newton, and if all of you are getting 100 Newton, then probably that is the only answer for this question. Moving on, guys. So we are done with this module. Now module 6 we are starting with. Page 49, module 6. Page number 49, question number 1. Come on, students, can we start with this module? The first question says, two sound waves having wavelength 87 and 88.5 centimeter, when they are superimposed, produce 10 beats per second. Find the velocity of sound wave. Okay, question number 1. Lambda 1 is 87 and lambda 2 is 88.5. And they are producing 10 beats per second. So capital N is 10 beats per second. We have to find velocity of sound. See, in such questions, the first step is to understand the meaning of number of beats. In such questions, the first step is to understand the meaning of number of beats. Now, students, can we say one thing, that number of beats is nothing but difference of frequencies? Number of beats is nothing but difference of frequencies. And we have two wavelengths with us. So lambda 1 and lambda 2. Out of that, lambda 1 is less than lambda 2. Lambda 1 is less than lambda 2. Therefore, can we say that N1 will be greater than N2? N1 is going to be greater than N2. So this number of beats is going to be written as capital N is equal to N1 minus N2 is equal to 10. Now, students, frequency is given by velocity upon wavelength. So this will be written as velocity upon lambda 1 minus velocity upon lambda 2 is equal to 10. Make sure that these values are in centimeters. So when you substitute and solve it, the answer that you will get is also going to be in centimeters per second. You all know, students, that you all have to watch the video in full screen mode. Then you will be able to see everything that I am writing. So if you are not observing in full screen mode, please switch to the full screen mode. Now tell me, students, is it clear so far? Any doubts so far? Okay. Now, students, if you have a look at question 9, I will say question 9 is similar to question 1. Question 9 is similar to question 1. Question number 2. A tuning fork C produces 8 beats per second. Okay, students, before we proceed with this question, I would like you all to pay attention to question 4, and question 4 is also similar to question 1. So question number 1 if we understood, then question number 4 and question 9, both the questions we will understand as well, and you will say both the questions are homework. Both the questions are homework. Okay? So I'm going to erase this and we are going to start with question 2. So pay attention, question 2 is a very interesting question. A tuning fork C produces 8 beats per second with tuning fork D of frequency 340. So frequency of D is 340 and number of beats initially is 8 beats per second. When the prongs of C are filed a little, number of beats produced per second decreases to 4. So final number of beats is 4 beats per second, and the frequency of C before filing its prongs. So frequency of C before filing. Now students, I am going to explain first the meaning of filing and loading. Understand this. That on filing, frequency increases. On loading, frequency decreases. Filing frequency increases and loading frequency decreases. So just remember this, everybody. This is very, very important to understand, that whenever filing word is involved, remember that frequency always increases, and after loading, frequency decreases. Is that clear, everybody? I'm going to erase this. Now let us write down the two parts, that is before filing. Let us write down before filing. Before filing, students will have two conditions. See, number of beats is 8. Number of beats is 8. Now there is some student in the chat who is spamming the chat, Mikhail Talfen. If you are not interested in lecture, you better leave. Don't spam the chat with unnecessary and useless comments. Okay? Now before filing, before filing, frequency of C can be greater than frequency of D. and or it can be frequency of D is greater than frequency of C. Either of it. Either C will be greater, see, because we don't know the frequency of C value, we don't know. So either C will be greater than D or D will be greater than C, either of it. So if this situation comes true, then NC minus ND is equal to 8. Now ND value is 340, so NC minus 340 is equal to 8, and so NC will become 348 Hertz. And here, if D is greater than C, if D is greater than C, then we will write ND minus NC is 8, because the initial number of beats is 8. ND value is 340 minus NC is 8, and you get NC as 332 Hertz. We get the value as 332 Hertz. So either 348 is the correct answer before filing, or 332 is the correct answer. Either of it. 348 or 332. Okay, either of it is correct. Now, which one is correct, that we have to understand. And for that, we have to consider final beats condition. That is after filing. So students, pay attention how we are solving this. Here we are going to write after filing. But students, make sure that these conditions are remaining the same. So these conditions should remain the same. These conditions should remain the same. So NC can be greater than ND because we don't know the value of NC, or ND can be greater than NC. Either of it. Either of it. Now, the final frequency, all of y'all, final number of beats is 4. So NC minus ND is 4. The value of NC is not known. ND is 340. So this becomes 344 Hertz. This becomes 344 Hertz. And here we will say ND minus NC is 4. Alright. ND value is 340. So if you substitute, you should get NC as 336 Hertz. 336 Hertz. So now students, tell me, if you say that 348 Hertz is the correct answer, okay? So before filing, it is 348 Hertz. Then after filing, we are getting 344 under the same conditions. Before filing, 348. Under the same conditions, after filing, 344. And this is wrong then. Why is this wrong? Because after filing, what did we learn? Frequency should increase. After filing, frequency should increase. So if you consider 332 hertz to be the correct answer, so 332 hertz after filing becomes 336. Frequency should increase. So it is increasing, all of you all. Hence, the correct answer to this question is 332 hertz. The correct answer is 332 hertz. So students, you copy this, and after copying I am going to give you one statement. Okay, students, now I am going to give you a statement. So write the statement. Write the statement. If frequency of tuning fork C, if frequency of tuning fork C before filing is 348 hertz, if frequency of tuning fork C before filing is 348 hertz, then after filing the frequency cannot reduce to 344 hertz, cannot reduce to 344 hertz. Hence frequency of tuning fork C before filing is 332 hertz. Is 332 hertz. Okay, students. So this was question number 2. Now question number 3. Question 3. A tuning fork B produces 4 beats per second with a tuning fork C of frequency 384. So frequency C is 384. initial number of beats is 4 beats per second. 4 beats per second. When the prongs of B are loaded with a little wax, the number of B increases to 6 per second. NF becomes 6 beats per second after loading. After loading, what was the frequency of tuning fork B before loading? So we can say we have to find frequency of B. We have to find frequency of B. Is that clear? This is our question. Now, how to proceed? So when we talk about the solution, here loading is taking place. Then here we'll write before loading. Here we are going to write before loading. Now once again, students, two situations might take place. Two situations might take place. First situation, that frequency of B is greater than frequency of C. Second situation, frequency of B is less than frequency of C. Two situations might take place. So this will be written as NB minus NC. What was the initial number of beats? 4. Now the value of NC is 384. So this becomes 388 Hertz. And here NC minus NB will be 4. Students, as you see, NC is greater in this condition. So NC minus NB is equal to 4. So NC is 384. So NB will become equal to 380 Hertz. NB is equal to 380 Hertz. Okay. So we have two answers with us. Only one of them will be correct. So I'm going to make a note of the answers here. 388 or 380. $388 or 380. 388 or 380. So in order to find the correct answer, what we shall do? We'll erase this. And tell me, this entire condition we had written was before loading. So now we are going to write after loading. Now students, after loading the number of beats become 6. So 6. Now once again substitute. NB is not known. And NC is 384. So 384 plus 6 is 390 Hertz. 390 Hertz. And here, if we solve as per this second condition, then we'll get NB is equal to 378 Hertz. We get it as equal to 378 Hertz. Is that clear? Moving on. Now students, if you consider 380 as the correct answer, then after loading, the frequency cannot become 378. So 380 is wrong. Oh, I'm sorry. If you consider 388 Hertz as the answer, then after loading, frequency cannot increase. So 388 is wrong. Because loading, we know the frequency decreases. So which one is the correct answer, all of you all? Yes, students. You can just refresh it and I guess it will be clear. So copy this. Yes, Karthik. I am going to explain. Students, are the questions clear to you? Now, all of you all, let us physically understand what do you mean by loading and filing, because many students are asking the question that, sir, what do you mean by loading and filing? See, loading is the process of decreasing frequency. Loading is the process of decreasing frequency. Now students, how do you decrease the frequency? If this is a tuning fork, and let us say its current frequency is 256 Hertz, let's say. So in loading, what will you do is, these are the prongs. These are the prongs of tuning fork. So you apply wax. In loading, you apply wax to the prongs. Now, as you see that after applying wax, the prongs are become thick. They have become thick. If the prongs have become heavier, their frequency is going to decrease. So this is what you mean by loading. Okay? And now let us understand what do you mean by filing. Let us understand the meaning of filing. Filing. In filing, it is a process of increasing frequency. All right. Now, how do you increase the frequency of a tuning fork? If this is a tuning fork and these are prongs of tuning fork, then you will start filing the prongs. It means you will start making the prongs thinner. You will start making the prongs thinner. So if you go on filing it, so prongs will go on becoming thinner and thinner like this. See, the prongs are comparatively thinner from the first situation. Then the prongs have become light, and if the prongs are light in weight, their frequency would increase. So students, I hope this part is clear to you all. Moving on. Now students, I would like to solve question 7th. I would like to solve question 7th. In a set of 21 tuning forks are arranged in a series of decreasing frequencies. So capital N is 21 forks and they are arranged in decreasing order. Each tuning fork produces 4 beats per second. So X becomes equal to 4 beats per second. If the first fork is octave of last, frequency of first is octave of frequency of last. Find frequencies of first, last and 10th fork. We have to find 3 values: frequency of first, last and 10th fork. Now students, I would like you all to focus on this word octave and remember this, that in musical sound octave means twice. So N1 is twice of N21. The meaning of octave is twice. Remember this. In musical sound, octave doesn't mean 8. Octave doesn't mean 8. Octave means twice. Understood everybody? Now, we are arranging in decreasing order. Okay? So just think about this. If at all N1 is 100, suppose 100. Suppose, example. Then what will the value of N2 be? Number of beats is 4 and it is decreasing. So it will become 96. N3 will become 92 and so on. So if we say that the value of N1 is N1, suppose, then value of N2 is going to be N1 minus 4. Value of N3 is going to be N1 minus 8. A good student can also write this as N1 minus 2 into 4. Alright? Alright? So based on this, we are going to write generalized equations. So we can say that since frequency of first tuning fork is N1, therefore N2 is going to be N1 minus 4, N3 is going to be N1 minus 2 into 4. Similarly, students, what will N10 be equal to? N1 minus 9 into 4. And similarly, N21 will be equal to N1 minus 20 into 4. I hope you are able to understand this part, everybody. I hope you are able to understand this part, everybody. Now we are going to substitute it. So we know the relation that N1 is 2 times of the last frequency. So N21 is equal to twice N1 minus 80, and N21 becomes equal to 80 Hertz. Therefore N1 is how much? 160 Hertz. Now students, we have to find value of N10. So this N10 will be equal to 160 minus 9 into 4, that is 160 minus 36. That's 4, that's 2, that's 1. Hertz, that is the answer. Now students, you all copy this, and I am going to change the setup to laptop. Right now I am not having any connectivity issues, so I can shift the setup to laptop, and the sound also that you are having right now, that drilling sound won't be audible. So just give me 2 minutes, I am going to change the setup. Okay students, I am closing this particular stream. It will be on YouTube only. Everyone, the lecture is going to be on YouTube only. Just give me 2 to 3 minutes so that I can give you all a new link. Okay, but it will be on this channel only, don't go anywhere else.